All right, guys, welcome back. Believe it or not, this is the last lesson of AP Calculus before your calc exam. So after this, you'll be reviewing for your last test as well. I believe we'll have a quarter test also. And then when we get back from spring break, we will go in review mode and really review until the AP exam in May. Okay, so this last lesson is a real easy one. So it's a good note to end on. What I'd like for you to do is find the limit as x approaches 3 of the quantity x minus 3 divided by x squared minus 9. So if you would pause the screen, go ahead and find that limit, and we'll see how you did. Okay, well, if you did it correctly, you should have gotten 1/6. So let's apply kind of our pre-calc rules, I guess, here. So the first thing you always want to check is to plug in 3 for x, right? And you get 0 over 0, which means do more work. So what's the more work you did? Hopefully it was to factor the denominator into x plus 3x minus 3. Well, from there, the x minus 3's cancel, and you're left with 1 over x plus 3. And at this point, you can plug the 3 in for x, right? So you get 1 over 3 plus 3, which is 6. So your final answer should be 1/6. Not bad at all, right? However, there's an even faster way of doing this, believe it or not. If you have an indeterminate form, meaning 0 over 0, like we did here, or like infinity over infinity, then what you can do is apply L'Hopital's rule. And what L'Hopital says is, we'll go ahead and take the derivative of the numerator. So what would that be? That would be 1, right? And then take the derivative of the denominator. What would that be? That would be 2x. Derivative with respect to x both times. All right, now try plugging in 3. What do you get? 1/6. Done and done. Cool? Okay, so here is what L'Hopital's rule says. It says if the limit as x approaches a of, that should really be f of x over g of x is indeterminate, meaning 0 over 0 or infinity over infinity, then all you have to do is compute the limit as x approaches a of f prime of x over g prime of x. All right, so just take the derivative of the top, take the derivative of the bottom, and then try plugging in a. Now, if you get an indeterminate form again, like 0 over 0 again, all you have to do is apply L'Hopital's rule again until you don't have an indeterminate form. But you have to check for 0 over 0 or infinity over infinity every time. All right, think about why this makes sense. What question does the derivative answer again? It answers the question, how fast? So in a way, we're seeing, well, which one gets there faster, the numerator or the denominator? We're talking about growth here. So it's kind of the intuitive explanation of L'Hopital's rule. All right, let's find some of these limits. We did the first one together already, right? So we noted that we did start with 0 over 0 when we plugged in 3 for x. So when you take the derivative of the numerator with respect to x, you get 1. Take the derivative of the denominator, you get 2x, and then you can plug in 3 for x and get 1/6. Okay, so let's try these two. So the limit as x approaches 0 of e to the 2x minus 1 over x. This one is kind of one of those hidden limits. It's actually a derivative question. But if you don't recognize that, then we can just go ahead and apply L'Hopital's rule, right? So before we do that, though, we have to do what? You have to plug in your limit and see if you do get an indeterminate form. So e to the 0 is going to be 1. 1 minus 1 is 0. So I have 0 on top and certainly 0 on bottom. So we're good to apply L'Hopital's. So derivative of e to the 2x with respect to x is what? Do we need any rules, by the way? You need chain rule, right? So 2e to the 2x, differentiate the mom, you get e to the 2x, then differentiate the baby, you get 2. All right, derivative of 1 is 0, so we're good there. And then the derivative of x with respect to x is 1. All right, now we can plug in 0, so I have 2e to the 0. Well, anything to the 0 is 1, so 2 times 1 is 2, and that's my final answer there. All right, write this one down in your notes. You have the limit as x approaches infinity of ln of x divided by x. So if we want to use L'Hopital, the first thing we need to do is check for an indeterminate form. Well, ln of quote-unquote infinity, if you will, is what? Think about the graph of ln. What does that look like? It's the inverse of e to the x. It looks like this. So it is increasing on its entire domain also, but it's increasing very slowly. However, as x approaches infinity, what does y approach? It still approaches infinity, still gets larger and larger, it just approaches more slowly, and that's okay. So I have infinity in the numerator, infinity in the denominator, so that's an indeterminate form, so we can go ahead and differentiate top and bottom, apply L'Hopital's rule. So the derivative of ln of x with respect to x is 1 over x. Derivative of x is 1. So I'm left with just 1 over x. Now plug in infinity. So you have 1 over infinity, if you will, or tiny over huge, or if you learned Bobo Botten, what do we have here? The answer is 0, right? Bigger on bottom, 0. Okie doke, that is pretty much it. Okay, you have some in your homework that ask you to find the limit, A, using old techniques, and B, L'Hopital's way. So I thought we would do one like this to review the old techniques. If you feel good, then you can stop the video and go ahead and start your homework. But if you want this review, we'll do this as our final example. Okay, so on the left side, I'm going to use old techniques. I'm going to use pre-calc techniques. And on the right side, I'm going to go ahead and use L'Hopital's rule. And hopefully L'Hopital's is quite a bit faster, right? Okay. Okay. So first thing, even using pre-calc methods, I always want to plug in your A value first. So I have square root of 9 plus 7. Well, 9 plus 7 is 16. So I have square root of 16 minus 4. 4 minus 4 is 0. So I have 0 on top, and I also have 0 on bottom. So how do we remember even how we can work with this using pre-calc techniques? We're going to multiply both sides by the conjugate, in this case of the numerator, since it has the square root portion. So I'm going to multiply both numerator and denominator by the quantity, the square root of x plus 7 plus 4. Right, and what I do to the top, I need to do to the bottom. Okay. All right, let me do this. Okay, so now let's go ahead. What we'll do is distribute the numerators, keep the denominators in factored form. So when I distribute, square root of x plus 7 times square root of x plus 7 just becomes plain old x plus 7, right? And then what happens here is I have square root of x plus 7 plus 4, and then square root of x plus 7 times negative 4. So those are going to cancel. Remember, we didn't even bother writing those typically in pre-calc. All right, and then the last term is going to be negative 16, negative 4 times positive 4. Okay. Go ahead and leave the denominator like so. All right, now what? We'll now simplify the numerator. It becomes x minus 9, which is good news for us, right? Because that is the problem factor, and that's what was giving us the 0 in the denominator. Okay, so now I can go ahead and cancel out the x minus 9s. Don't forget your understood 1 in the numerator. So I have square root 1 over the square root of x plus 7 plus 4. All right. Okay, now we can plug in x, 9 for x. So I have 1 over the square root of, 16 plus 4. So I have 1 over 4 plus 4, which is 1 over 8. Okay, not terrible, but it took some time. Okay, why don't we try using L'Hopital's rule now? So I already know that it is an indeterminate form, right? I get 0 over 0 when I plug in 9 for x. All right, so then let's differentiate numerator and denominator with respect to x. Ideas, should we first rewrite this? Like so? You good with that? Okay, so if I differentiate the numerator, I would get 1/2 times x plus 7 to the negative 1/2. And then technically times 1, right? Chain rule. Derivative of 4 is 0, so we're okay there. This is a times, not a minus. Then the derivative of the denominator is 1, right? Okay, so now I think we're good to plug in 9. So how about we rewrite this, though, as 1 over 2 times the square root of x plus 7. Okay, so if I plug in 9 now, I have 2 times the square root of 16. Well, PEMDAS do square root of 16 first, so that's 4, and 2 times 4 is 8. So we get the same thing both ways. So in this case, both maybe just about the same number of lines, but I think L'Hopital's went a little bit faster, yeah? All right, well, that's it, guys. Again, if it asks you to use, find the limit using both techniques, please do so. And congratulations, you are done with AP Calculus lessons. So I'm so proud of you all and can't wait to see you all in person. And when we get back from spring break, then we will start reviewing for the AP exam. All right, good luck, guys.